In this last video of this module, I'm going to walk you through the steps of an independent samples t-test from beginning to end. This will come in really handy when you're doing your special assessment this week because we're walking through the same process, you'll just use different data in your assessment. So make sure you really understand the contents of this lesson before you go on to do your special assessment. Here is the scenario. An educational psychologist wants to know if having computers has an effect on grades for elementary school students. So one group of students has computers and the other group of students does not have computers in their homeroom. And at the end of the year, the average grade is recorded for each student. So we have an independent variable of the grouping variable. Either students are in the computer classroom or in the classroom without computers. That's the independent variable. And the dependent variable, which is going to vary according to group membership, is the average grade. And the question is there a significant difference between these two groups? So here's the data for the two groups. We have the mean of the first group and the mean of the second group. The first group is computer, the second group is traditional. We have sums of squares, and as a reminder, sums of squares is the sum of the squared deviations from the mean. It's what we use to find out variance and then standard deviation. And our n is listed as well for both groups. All right, let's go ahead and work this out on the board.
So I've added our information on the board with our n, our means, and our sums of squares. And we can get started with setting our hypotheses. So my null hypothesis first is going to be that the mean of the first group minus the mean of the second group is equal to 0. That's the null hypothesis, that there's no difference between these two groups. The alternative hypothesis is going to be that the mean of the first group minus the mean of the second group is not equal to 0. So that's our alternative hypothesis. Let's go to step 2. For step 2, we need to find out what our critical boundaries are going to be. And in order to do that, we need our degrees of freedom. The formula for degrees of freedom, again, is n minus 1 of the first group plus n minus 1 for the second group. So we have 16 in each group. So 16 minus 1 plus 16 minus 1, essentially 15 plus 15. Our total degrees of freedom are going to be 30. And now we can take that total degrees of freedom and look at our t-distribution table. Let's take a look.
Our degrees of freedom are 30. We're looking for a two-tailed test with alpha of 0.05. If we draw an imaginary line down, we end up with 2.042 as our critical t-value. Now what we're going to say is plus or minus 2.042 because this is a two-tailed test, meaning that our critical areas are in the left tail and the right tail. We don't know in which direction our sample mean may go. We don't know if the grades are going to be higher or lower. So it is a two-tailed test at plus or minus 2.042 for the critical T level.
Now it's time to look at our calculations. And I've written the 3 different formulas that you're going to need in order to get this done. So our T formula has the mean of the first group minus the mean of the second group divided by the standard error of the mean difference. And how do we get this? Well, here's the formula for the standard error of the mean difference. It's the pooled variance divided by n plus the pooled variance divided by n. Add that all up and take the square root of it. And then finally, to get the pooled variance, which you're going to need for this formula, we take the sums of squares of group 1 plus the sums of squares of group 2 and divide it by the degrees of freedom in group 1 and degrees of freedom of group 2. So 3 different formulas all told to calculate the t statistic. So we're going to start at this lower level first because we've been given the sums of squares, and here they are in each group. So I'm going to add those up, 1005 plus 1155. I'm going to divide that by the degrees of freedom for both groups. We already determined that the degrees of freedom is n minus 1, so 15 in each group for a total of 30. So our pooled variance is going to be 2160 divided by 30, which is going to give us a pooled variance of 72. Now that we have our pooled variance, we can plug that into the standard error formula. That's what's coming up next. So we have 72 as the pooled variance here. Let's plug it into our formula. We have 72 divided by 16 plus the pooled variance again, 72 divided by the n of 16. So 16 goes into 72 4.5 times. Remember, we're doing the square root of this though, aren't we? We have to take the square root of it. So 4.5 plus 4.5 is 9. The square root of 9 is 3. So our standard error of the mean difference in this case is 3. Now we can plug it into the t formula. So for our t formula, we're going to take the mean of group 1, 86, minus the mean of group 2, 82.5, and we're going to divide it by the standard error of the mean, which we already decided was 3. So we have 3.5 divided by 3, which is going to give us a t of 1.17. That is our t-value. So we have to ask ourselves, is that more extreme than our preset alpha level where we found a t of 2.043? And the answer is, it's not as extreme. It doesn't fall into that critical area, does it? So let's take a look and see how we would interpret this.
When we've completed our t test, we're going to make a decision. And part of making that decision is presenting the data in statistical notation. That's part of it. So you have right here a t that is in italics with the number 30 next to it. That's our degrees of freedom. We have equals 1.17. That was the t that we calculated for our mean differences for our sample. We have a p that is greater than 0.05. Now, how do I know that it's greater than 0.05? 0.05 is our alpha level. That is the critical region that we set up. If our statistic does not fall within those critical areas, one of them, we say that our p-value is greater than 0.05. The probability is greater than 0.05 that we would find our t-statistic if the null hypothesis is true. So in this case, we failed to reject the null hypothesis. And the very last step is we need to put it in our own words. There's a couple different ways you could say it. You could say that computers in homeroom do not impact grades for elementary school students, or you could say there was not a significant difference between the two groups of students. We actually don't calculate effect size in this case because we didn't have a statistically significant result. If we did, we could either use Cohen's d or we could use r squared, but we're not going to in this case. So let's review the 4 steps of hypothesis testing, and this will help you out quite a bit with your special assessment. The first thing you're going to do is you're going to set your hypotheses, your null and your alternative hypothesis. The next thing you're going to do is you're going to either determine the critical boundaries for a 2-tailed test or boundary for a 1-tailed test. You're going to complete the t-statistic calculation, and you're going to display the results using that statistical notation I showed you a couple slides ago. And then you're going to make a decision. You're going to either reject or fail to reject the null hypothesis, and finally you're going to state your findings in words. I'd like to end with a model for how to report results, and this will be very helpful when you complete your special assessment. An independent samples t-test was conducted to determine if student grades differed in classrooms with computers and classrooms without computers, and then the statistics are reported. We fail to reject the null hypothesis. Having computers in homeroom does not impact grades for elementary school students. So let's take a look at the required elements. First, you need to provide a summary of what the study was about. Provide next the statistical notation as we've talked about. Decide on what your decision is going to be, either fail to reject or reject. And then write down in words what all of this means. So 4 different parts. So when you complete your special assessment, make sure you have these 4 parts. Okay, I'm here if you have questions, and good luck with everything this week.